Hey class, this is Mr. Ullman. We're going to try something new today. Instead of doing a PowerPoint that some of you have difficulty opening or reading, we are going to do YouTube. And I've never done this before, so please bear with me, and we'll see how this turns out. So a couple things here. For one, I've been writing a lot with my Sharpie marker, so if I stammering or stuttering, just like that, or if I don't speak very clearly, it's probably because the fumes are kind of getting to me. It's pretty powerful. So anyways, and secondly, I know that last slideshow was some brand new stuff, which can present some difficulties. It was pretty tough. So what we're going to do today at first is review that a little bit and make sure everybody has that down first before we move on to our next lesson, which is actually pretty short, so that's pretty cool. So anyways, let's begin here. So I hope you can read everything, and let's see what happens. So let's see, the first thing that we did was we learned to read the slope of a graph, and basically we learned that that was our rise over run. So our first graph here, we can start at any point really, any point on the function, any point on the line, and find our slope. So let's start right here. We don't always have to start at the origin or where it crosses an axis. Let's start right here. Let's see, our run would be from here to here. So that's 1. Our rise would be here to here. So that's 1, 2. So run is 1, rise is 2. So it's rise over run, so our rise was 2, our run was 1. 2 over 1, rise over run, our slope is 2. Okay, let's look at our second graph, just for another example. Okay, so here, let's see. Oh, first off, is this a positive or a negative slope? It's looking pretty negative to me. Okay, so let's find the slope. Now, since it's convenient, we don't have to, but since it's convenient, let's start at the origin. Let's see, what is our run going to be? Our run is going to be 1, let's see, 1, 2, 3, and our rise is going to be 1 down. 1 down is going to be a negative rise. So our run is 1, 2, 3, our run is 3, our rise is negative run, 1. Rise over run, negative 1 over 3. Our slope is simply negative 1/3. That can't reduce, so we leave it at negative 1/3. Alright, so far so good. Now we also learned how to find the slope when we are just given 2 points on a line, on a function. Now this was probably the most difficult part, but I think it's the most fun, and I really hope you enjoyed it too. Alright, so let's see, our first line, we were given 2 points. Negative 1, 3 is our first point, and then 2, negative 6 is our second point. And we learned to label these points as x1, y1, x2, y2. And what the 1s and 2s really mean is basically this is the x and y coordinates of our first point, and this is the x and y coordinates of our second point. That's all they really mean. So if that was confusing, I'm sorry, but that's hopefully understood now. So we learned what our slope equation is. It's y2 minus y1, or y2 minus y1, over x2 minus x1, x2 minus x1. So basically, after we've labeled these points, we just substitute the coordinates in for the proper place. So y2 minus y1, or y2 was negative 6, minus y1, or y1 was 3, so 6 minus 3, over, or divided by, x2 minus x1. Our x2 is positive 2, minus our x1, which is negative 1. So 2 minus negative 1. And this reduces down to negative 6 minus 3 is negative 9. And then 2 minus negative 1, the minus negative turns into a positive. So that's 2 plus 1. So 2 plus 1 is 3. So we have negative 9 over 3, and it reduces. Always remember to reduce when you can. It reduces just to negative 3. Okay, so let's think about this. This is kind of in abstract, this is kind of confusing. I agree. It can be a little difficult. But really, I hope to show you that that's the exact same thing that we do whenever we're reading a graph. For instance, this is the line that we just worked out up here. Let's see, these are the exact 2 points that I gave you. Negative 1, 3, negative 1, 3, okay? And then 2, negative 6, 2, negative 6. How about that? So, if we were to find the slope given these 2 points on our line, when we work with these 2 points, how would we do it? First, we would find the run. The run's always easiest to find first. We're going from here to about here, right? Right here. So here to here, our run is 1, 2, 3. And what's our rise? Our rise is 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's down, so that's a negative 9. So we have rise over run. Rise is negative 6 minus 3. Our run is 2 minus negative 1. So we're going to have negative 9 over positive 3, which is exactly what we did. So that's going to be negative 3. All right. Now, if you don't believe me, let's look at a second example here. All right, so again, we're given y2 minus y1 over x2 minus x1. And like I have right here, this is the exact same thing as rise over run. So our points that we're given are 2, 2, and 3, 4. So we would label our points as x1, y1, x2, y2. And we would simply substitute them like we know how to do. So our y2 is 4 minus y1, which is our 2, over, let's see, our x2, which is 3, minus our x1, which is 2. This reduces down to 2 over 1, so our slope is simply 2. Now, here is our line, which is what we just found the slope for. We were given the same 2 points. This is 2, 2, and this is 3, 4. So how would we find this if we were just reading it, just like normal? We would do our run is 1. We're going from 2 to 3, so our run is 1. Our rise is from, let's see, 2 to 4. So 1, 2. Our rise would be 2. So our run is 1, rise is 2. So we would have a run over rise, that's 2 over 1, which is exactly what we have up here. 2 over 1 is a slope of 2. So that's the exact same thing. Hopefully that puts this equation in context and makes it a little easier for you. So basically what we're doing is the change in y over the change in x. That's exactly what we're doing here. Okay, so moving on. Now we're going to get into our new lesson. And before I get into this, YouTube only does 10-minute videos, I think. So I'm going to stop this at 10 minutes, and then you will have another link to log on to continue this lesson. So anyways, don't be confused. There's more coming, more fun for you. Okay, so we are talking about rate of change. And this goes in your notes, please. Rate of change is a change in one quantity with respect to another quantity. And this is basically going to be our slope. You remember in science class we often compare two different things, like ice melting. So we might compare the temperature of the ice with the time that has gone by. So that's comparing our two different quantities. And it's basically the change in temperature over the change in time, if we were given that example. But here, it's basically our change in our y value over the change in x value, which is exactly what we just talked about 2 minutes ago. And this is actually going to be our slope. That's pretty cool. So keep everything in perspective and in context. Our rate of change is actually going to be our slope. Okay, so let's look at an example. My electricity goes out, which is a very real possibility tomorrow or even tonight. Let's see. For every 1 hour, my house heat decreases by 10 degrees. This can be shown on a graph. Here we have time in hours and temperature in degrees. So which is our x's, which is our y's? All right, our time in hours is on our x-axis, so our time in hours would be our x-coordinates. Our temperature is on our y-axis, so our temperature is going to be our y-coordinates. Okay, so I'm going to stop it right here. Don't panic. Just follow the next link that I give you in your email, and we will pick up where we left off.